Hello everyone. Welcome back to the lecture series on business mathematics. This is our fourth lecture of this lecture series. So, as we know that in the third lecture we have discussed several examples related to arithmetic progression. We discussed how to find out the nth term of given arithmetic progression. We discussed that suppose we are having an arithmetic progression in which the sum of first n term is given, then how to find out its first four terms. We also discussed an example in which we have to find the sum of first n terms of given arithmetic progression. Right? So we'll continue discussing examples related to arithmetic progressions. So let us see an example. So the question is which term of the sequence which term of the sequence -3, -7, -11, -15 is 403, right? Also verify is -500 a term of this progression or not. Okay, so let us try to understand the question first. So here we are given a sequence -3, -7, -11, -15 and so on. We have to verify which term which term of this arithmetic progression is -403, right? -403 is a term of the sequence. It is given in the question. We have to verify which term of the sequence is -403. That means we have to find out the value of small n for which an is equal to -403. This is the first question of this example. Then we have to verify is -500 a term of this progression or not. That means we need to check is -500 is a term of this progression or not, right? So two questions are there in this example. Let us see the solution. So here, first of all, let us see. We can observe that the sequence -3, -7, -11, -15 is an arithmetic progression, right? See, this is an arithmetic progression. Why? Because we can observe that the difference between first term and second term, that is -7 minus -3. So you can observe that this is -7 and minus minus becomes +3. It is -4. Similarly, difference between third term and second term, -11 minus -7. So again minus minus plus 7, 11 minus 11 plus 7, that is again -4. Similarly -15 plus 11 -4, right? So the consecutive difference is -4 for all the given terms, right? That's why we can observe that this progression is an arithmetic progression. Okay, so this is an arithmetic progression. Now, what is the question? We have to find the value of n for which an is equal to 403. So, also let us note down the value of a1. What is a1? A1 is the first term, that is -3. A1 is the first term, that is -3. Okay. What is d? D, that is the consecutive difference. Just now we discussed that it is -4, -7 plus 3, that is -4, and an is equal to -403, right? An is equal to -403. This many things we are given in the question. What is the next? What is the question? We have to find out the value of this n, right? We have to find out the value of n for which an is equal to -403, right? So how to find out? We know the formula for finding out the nth term of an arithmetic progression, right? So we know that we know that for an arithmetic progression, an is equal to, we know the formula to finding out the nth term, first term plus n minus 1 into d. First term plus n minus 1 into d. We have all the values except the value of n. So let us put the values. An is equal to minus 403, right? We are given that an is equal to minus 403, equal to a1 that is minus 3 plus n minus 1 into d, n minus 1 into d. And what is the value of d? We are having the value of d, it is minus 4, right? It is minus 4. Let us simplify a bit more. Minus 403 equal to minus 3 plus, right? We are simplifying this bracket, n into minus 4, that is minus 4n, it is minus 4n, minus minus plus 4 plus 4, 1 into 4, that is 4, right? So see what we are having, minus 403, right? Minus 4, sorry, minus 3 plus 4, that is plus 1, right? Minus 3 plus 4, that is plus 1, right? Taking plus 1 on the left hand side, you will get minus 403 minus 1. Actually we are adding minus 1 on both the sides, right? I am adding minus 1 here, I am adding minus 1 here. Why? Because minus 3 minus 1, that is minus 4, minus plus minus 4 plus 4, that is 0, right? So actually we are adding minus 1 on both the side. So we are having minus 403 minus 1 is equal to minus 4n. So again here minus 4 is in multiplication, so when we take this minus 4 on left hand side, it will be going to the denominator. Once again we are not taking minus 4 on the left hand side, we are dividing the term with minus 4, right? We are dividing the term with minus 4. So what we will do, this is minus 404 divided by minus 4 is equal to n, because we are dividing with minus 4, so minus 4 is cancelled out. So this minus minus sign will also cancel out, and 404 divided by 4, so it is 101. We are having n is equal to 101. What does this mean? See here, we begin with an equal to a1 plus n minus 1d, right? That means we have taken that the nth term is 403, right? Our nth term is minus 403, and after simplification we are getting that n is equal to 101. It indicates that the 101th term of this progression is minus 403, right? So let us note down this fact. Therefore, the 101th term of given sequence is minus 403. So the first question is solved, right? See, the question is asked in a different way, but we are using the formula of finding out the nth term, right? So it is just a simplification. We are having the value of first term, we can find the difference, consecutive difference, and we are given that an is equal to minus 403. So putting all this value in this formula, simplifying, we are getting n is equal to 101. It simply indicates that the 101th term of this arithmetic progression is minus 403. Now let us solve the second part. Also verify, is minus 500 a term of this progression or not. So let us see how to solve. If possible, if possible, suppose that minus 500 is a term of given arithmetic progression. Right? If possible, suppose that minus 500 is a term of given arithmetic progression. Okay. We'll follow the steps we have followed for minus 403, right? Now here we have to verify is minus 500 a term or not. So what we will do, we'll assume that suppose minus 500 is a term of given arithmetic progression, right? That means for some n is equal to minus 500, right? If minus 500 is a term of given arithmetic progression, then there will be some n for which n is equal to minus 500. Now you know the values of n, right? N may be 1, 2, 3, 4, 5, and so on, right? Simply n is a natural number. N is a natural number, right? So what we will do, we'll assume that for some an is equal to, for some n we are having an is equal to minus 500. Again we'll use the same formula and we'll see what we are getting the value of n. If we get value of n to be some natural number, then minus 500 will be the term of given sequence, right? And if we are getting the value of n in fractions, then minus 500 will not be the term of given arithmetic progression, right? Why? Because we know that there may be the first term, second term, third term, fourth term, and so on. There will be not any 3 by 2 term, right? There will be no any 1 by 2 term. Okay, so n will be always a natural number. So let us see the solution. Let us see the solution. If possible, suppose that minus 500 is a term of given sequence. Therefore, there exists some n belongs to n such that an is equal to minus 500, right? There exists some n belongs to n such that n is equal to minus 500. Therefore, an is equal to a1 plus n minus 1 into d. Let us put the values. An is equal to minus 500 in this case is equal to a1. We know that a1 is equal to minus 3 and the consecutive difference is minus 4, right? So a1, that is minus 3 plus n minus 1 into d, that is minus 4. Let us simplify. Minus 500 is equal to minus 3 n into minus 4, that is minus 4n, and minus minus becomes plus 4, right? So again minus 3 plus 4, that is minus 1, sorry, minus 3 plus 4, that is plus 1, right? So taking plus 1 on left hand side, it will be minus 500 minus 1 is equal to minus 4n, right? Minus 3 plus 4, that is plus 1. So adding minus 1 on both the sides, we will get minus 500 minus 1 is equal to 41. So it is minus 501 is equal to minus 4n. We can observe that minus minus sign is cancelled out. So therefore we are getting that n is equal to 501 divided by 4, which does not belongs to n. That means which is not a natural number, right? If you find out 501 divided by 4, you will get the value 25 point something, right? 25 point something. Okay, so we know that n must be a natural number, right? The value of n must be either 1, 2, 3, 4, 5, and so on. So n must be a natural number, but here we are getting that n is equal to 501 divided by 4, which is not a natural number. That means what we assume that suppose that minus 500 is a term of given arithmetic progression is not true, right? Therefore our assumption is not true. That means minus 500 is not a term of given arithmetic progression, and this is your answer, right? Now see, this method of mathematics is called method of contradiction. Method of contradiction, right? That means the statement in which we are asked to prove something, right? So assume on contrary, right? So here we are asked to find out whether this minus 500 is a term of given sequence or not. So what we assume, suppose it is a term of given arithmetic progression, or it is a term of given sequence. Right? That means there must exist some n belongs to n for which n is equal to minus 500. Now move forward. Right? After simplification, we are getting something which is not true. Right? It means that the beginning step, the first step we have started, is also not true. What was the first step? Suppose that for n belongs to n, an is equal to minus 500. That means this statement is not true. This statement is not true. That means there exists no n belongs to n for which an is equal to minus 500, right? So ultimately, using the method of contradiction, we have proved that minus 500 is not a term of given arithmetic progression. Okay, let us move further. Let us see one more example. Okay, so the next question is, which term of the sequence, which term of the sequence 25, 24, 1 upon 4, 23, 1 by 2, 22, 3 by 4, and so on, is the first negative term. First negative term. Okay, so this one is a little bit different example. Here we are given a sequence. You can observe that the values of terms are decreasing. Here it is 24, this is 24 point something, this is 23.5, 22 point something, and so on. Right? That means the values are decreasing. So it may happen that after a certain stage, the values will be less than zero, because this is the sequence of infinite terms and values are decreasing, right? So after a certain stage, all the values will be negative values, right? So our question is to find out which term will be the first negative term. That means we have to find out the value of n such that an is the first negative term. Okay, we are not asked to find out the value of that particular term. We are just asked to find out the value of n for which n is less than 0. An is the first negative term. That means an is less than 0. Okay, so I think the question is clear. Now see, the terms are given as 24, 1 by 4. You know how to simplify this. Multiply these two terms, 24 into 4. Add this one plus 1 divided by numerator 4 as it is, right? This is how we simplify this term 24 1 upon 4. What we'll do, we'll multiply 24 with 4, add 1 divided by 4. Okay, so first of all we'll see whether the given sequence is an arithmetic progression or not, right? So let us see. Here a1 is equal to 25 and a2 is equal to 24 1 upon 4. Let us simplify this. So it is 24 into 4 plus 1 divided by 4. So it will be 24 into 4, that is 96 plus 1. So 97 divided by 4. Now let us find out the consecutive difference. So D is equal to A2 minus A1. What is A2? It is 97 divided by 4 minus 25, right? So see, in this term we are having 4 in denominator, while here we are having 1 in denominator, right? Since the denominator are different, we cannot directly separate these two terms. So what we will do, we will take LCM, or in simple word, What we will do, we will multiply this term and divide this term with 4. Right? We know that 4 upon 4, that is 1, and 25 into 1, that is 1. So what we will do, we will multiply and divide the term with 4. So now we can observe that the denominator of the second term becomes 4. Right? So this is 97 divided by 4 minus 25 into 4 divided by 4. So this is nothing but the 97 minus 25 into 4, that is 100, divided by 4, and 97 minus 100, that is minus 3 upon 4. So this is the value of our D, right? This is the value of our D. That means the consecutive difference between second term and first term is minus 3 by 4. Now let us find out the difference between third and second term. So A2 is equal to 24 1 upon 4, and A3, that is the 23 1 by 2, right? So what we will do, D is equal to A3 minus A2. So A3, simplify this term. This will be 23 into 2 plus 1 divided by 2 minus A2. A2 is this one, 24 into 4 plus 1 divided by 4. Okay. So this is equal to 23 into 2. So it is 46. 46 plus 1, that is 47 by 2, minus, we have simplified this term, it is 97 divided by 4. Again we can observe that the denominators are different. Here the denominator is 2, while here it is the 4. So to make this denominator to be 4, what we will do, we'll multiply and divide with 2, right? So 2 into 2, that is 4. So denominator becomes 4. And what in the numerator? 47 into 2, that is 94, divided by 4 minus 97 divided by 4. So it is 94 minus 97, that is minus 3 by 4. So you can observe that here also D is equal to minus 3 by 4. Right? So we will find out difference between A1 and A2, A2 and A3. Similarly, you can also find out difference between A3 and A4. Similarly, A4 minus A3 is equal to minus 3 by 4. This you have to verify, right? We have already find out this difference between first and second term, second and third term. Now we have to find out this difference, right? It will be minus 3 by 4. So what does this mean? This means that therefore given sequence is an arithmetic progression. Given sequence is an arithmetic progression. Now what is the question? The question is to find out which term of the sequence will be the first negative term. So let us simplify. Suppose that for n, an is the for an is the first negative term of given arithmetic progression, right? For n, an is the first negative term of given arithmetic progression. Okay, so it means that an is less than 0, right? An is less than 0 because it is a negative term. But we know the formula for an, right? Suppose you are given an arithmetic progression, then we know the formula to find out its nth term, an. So what is the formula? It is first term plus n minus 1 times d. So an equal to a1 plus n minus 1 times d, which is less than 0 as it is. Now let us put the values of a1 and d. What is a1? What is A1? A1 is the first term. Here we have mentioned that A1 is 25 and D is nothing but the minus 3 by 4. So A1, that is 25 plus n minus 1 D, and D is nothing but the minus 3 by 4. Just now we have mentioned that. Let us mention here also. This implies that D is equal to minus 3 by 4. So this is less than 0, this term as it is. Let us simplify this term. So n into minus 3 by 4, it is minus 3 by 4 n, and minus minus becomes plus 3 by 4, and this is less than 0. Right? This is less than 0. Now simplify this term, 25 plus 3 by 4. Now to add these two terms, what we require? We require the denominator to be same. So what we will do again? We'll multiply and divide this term with 4. Right? So this will be 25 into 4, that is 100 divided by 4, minus 3n upon 4 plus 3 by 4, which is less than 0. Right? Now see here. Now the denominator of first and third term is same, 100 by 4 plus 3 by 4. So it is 103 divided by 4 minus 3n upon 4 is less than 0. Right? Now see, the subtraction of these two term is less than 0. Right? This term minus this term gives us the negative number. It means that the value of the first term will be smaller than the value of second one, right? Because the number is negative, right? This term is smaller one and this term is bigger one. Only then you will get the negative value after the subtraction. Okay, so here a minus b is less than 0. It simply means that b is larger than a, so this number is bigger than this, right? This implies that 3n upon 4 is greater than 103 upon 4, and this 4 gets cancelled out. This implies that n is greater than 103 divided by 3. N is greater than 103 divided by 3. So 103 divided by 3, it is about 34.33. Right? 34 point, you can verify. 103 divided by 3, that is 34.33. Now let us understand once again. See what we have suppose that for n, an is the first negative term. We put the formula and we find out the value of n. N greater than 34.33. This indicates that whenever the value of n will be bigger than 34.33, then an will be less than 0. See, we started with an less than 0 and we are getting that n is greater than 34.33. Right? It simply means that whenever the value of n will be bigger than 34.33, then your n will be the negative number, and you know that the value of n always lies in the set of all natural numbers, and obviously the first natural number after 34.33 will be 35. Right? Once again, here we are getting that if an is less than 0, then n must be bigger than 34.33. Right? It indicates that whenever the value of n will be greater than 34.33, then an is less than 0. Right? And we know that the value of n will be always 1, 2, 3, 4, 5, like this. It will be some natural number. And obviously the first natural number after 34.33 will be 35. So this implies that for n equal to 35, A35 is the first negative term of given sequence, and this is your answer. Okay. Again, see, we have used just the formula to find out the nth term of an arithmetic progression, right? But to reach out there, First of all, we verify that the given sequence is an arithmetic progression, and then we use the formula to find out nth term of given arithmetic progression. We use the fact that n for an must be less than 0, right? So we use the fact that an is less than 0, and we simplify. We are getting that n greater than 34.33, and we know that the n lies in the set of all natural numbers. So the first natural number occurs after 30.33, that is 35. It simply indicates that the 35th term of given arithmetic progression is the first negative term, right? And this gives us the answer. Okay, so I hope this solution is clear to you. Let us see one more example. Find the 15th term. Find the 15th term from the end of the sequence. From the end of the sequence 7, 10, 13 up to 130. Okay, let us try to understand the question first. See, we have to find out the 15th term from the end, right? We are not asked to find out the 15th term. 15th term from the end. That means the first term is 7, second is 10, third is 13, and the last one is 130. Now, from 15th term from the end, so from the back side, okay? So we have to find out the 15th term from the end. So let us see how to solve this. First of all, observe that this one is an arithmetic progression 7, 10, 13, 16, and so on. So the difference is 3, 3, 3, 3. So we can observe that given sequence is an arithmetic progression with a1 is equal to 7 and d is equal to 3. Right? D is the consecutive difference between any two terms. So a1 is equal to 7 and d is equal to 3. Now, how we can identify which term will be the 15th term from the end? Right? How to find out that which term of the sequence will be the 15th term from the end? So first of all, you should know that this last term is which term, right? That means for n, what for which value of n, an is equal to 130. So first of all, we'll try to identify the number of this term 130. So for that, let an is equal to 130. Okay, an is equal to 130. Also, we know that an is equal to a1 plus n minus 1d. Now you have the value of an, you have the value of a1, you have the value of d. Put and simplify, you will get the value of n. So an, that is 130, is equal to a1, that is 7, plus n minus 1 d, and d is equal to 3, you can observe. So let us simplify this. This is 130 is equal to 7, plus simplify this, n into 3, that is 3n, minus 1 into 3, that is 3. So 7 minus 3, 7 minus 3, that is 4. Taking 4 on the left hand side, it will be 130 minus 130 minus, this will be 4, that is equal to 3n, right? So this is 130 minus 4, 130 minus 4, that is 126, divided by 3, that is equal to, when taking 3 on the left hand side. So this implies that n is equal to 42. Okay. So here we have proved that for n equal to 42, n is equal to 130. That means the last term of this given sequence is 42. Therefore, A42 is equal to 130. Now, what is our question? Our question is to find out the 15th term from last. Now you can verify which term will be the 15th term from last, because the last term is 42. Okay. So therefore, see, the last term is 42. So we have to identify the 15th term from n. So now, therefore, the 15th term from the end is, the 15th term from n will be 42 minus 15, 42 minus 15 plus 1, right? Because if you don't add plus 1, then it will be the 16th term from last. Okay. So 15 term from n is equal to 42 minus 15 plus 1. So it is 27 plus 1, that is 28. Okay. So we have to find out the value of A28, right? We have to find out the value of A28 from the beginning, right? So let's mention this fact. Thus, the 15th term from the end is the 28th term from the beginning. Okay. So now you know the formula for A28. A28 is equal to A1 plus N. N is equal to 28 in this case, minus 1 into D. What is A28? That you have to find out. What is A1? A1 is equal to first term, that is 7. A1 is equal to 7 plus 27 into D. And what is D? D is equal to 3. D is equal to 3. So now let us simplify this. 27 into 3. Right? So therefore A28 is equal to 7 plus 27 into 3, that is 81, and 81 plus 7, that is 88. Okay. So therefore the 15th term from the end is 88, and this is your answer. Okay. So see what we did in this question. First of all, we find for which value of n is equal to 130. That means we find the value of last term, right? So we identify which term is the last term. So here we got that the 42th term is the last term, right? 42nd term is last term. Now we have to find out the value of 15th term from last. So 42 minus 15, it will give you, you can verify that it will give you the 16th term from last. In order to find out the 15th term from last, what we will do? 42 minus 15 plus 1. So it is 28. So just we have to find out the value of A28, because the 15th term from the end is nothing but the 28th term from the beginning. And you know that how to find out value of AN. So an is equal to a1 plus n minus 1 into d. Put the values and simplify, you will get the answer. So I hope the solution is clear to you. Okay, let me give you an exercise. Right? You have to solve this question. We are given that if a square into b plus c, b square into c plus a, c square into a plus b are in arithmetic progression, then prove that either A, B, C are in arithmetic progression, or or AB plus BC plus CA is equal to 0, right? Okay, see, we are given that A square into B plus C, B square into C plus A, C square into A plus B are in arithmetic progression, right? This we are given in the question. Then we have to prove that either A, B, C are in arithmetic progression. That means either B minus A equal to C minus B, or AB plus BC plus CA is equal to 0. So what you have to do, these three terms are in arithmetic progression. That means difference between second term and first term will be same as difference between third term and second term. So you have to use like this: B square into C plus A minus A square into B plus C. This is equal to C square into A plus B minus B square into C plus A. Right? Now, simplifying these two terms, you will get some two brackets is equal to 0. So, one bracket will give you AB plus BC plus CA equal to 0. Another bracket will give you this one, B minus A is equal to C minus B. And you know the fact that if X into Y equal to 0, then either X equal to 0 or y equal to 0. At least one of them must be 0. Only then the product will be 0, right? For numbers, it is not possible that two product of two number is 0. So if you are having x into y equal to 0 as far as the numbers are concerned, then at least one of them must be 0. Okay. So if x into y equal to 0, then either this equal to 0 or this bracket equal to 0. After simplifying this term, you will get something like this. Say this is x, this is y, and y must be AB plus BC plus CA. So it will directly give you AB plus BC plus CA equal to 0. And simplifying the other bracket, you may get that B minus A is equal to C minus A. Okay. So if this happens, then we say that A, B, C are in arithmetic progression. Otherwise, AB plus BC plus C equal to 0. Okay. So this one is an exercise for you. Okay. Okay, so I think this is enough for today's lecture. I will continue discussing on various kind of progressions in next lecture. Thank you.